Hey math kids, today we're going to talk about definitions. Um, so let's start with rational numbers. So rational numbers are integers divided by integers. But the bottom can't be 0. Also, if we have an integer that is even, we know that it has to be able to be written as 2 times an integer. Okay. For example, 2 can be written as 2 times 1, 4 can be written as 2 times 2, 6 can be written as 3 times 2, etc. Okay. Odd has to be able to be written as 2k plus 1, where k is an integer. And so like 3 could be written as 2 times 1 plus 1. 5 could be written as 2 times 2 plus 1. 7 could be written as 2 times 3 plus 1, and so on. Okay. Now let's jump into an example. And they want us to prove that 0.13 repeating is contained on the set of all rational numbers. So basically it just wants us to prove that a repeating decimal, but a specific repeating decimal, is rational. We've learned that rule before, but now we're going to prove for a specific case. Okay, so we're going to let x equal 0.1333, which is like saying 0.131313 forever. Okay. Now, if we multiply both sides by 100, like if we just have x, so essentially I'm ignoring this piece. If I multiply this by 100, I get 100x. If I multiply this by 100, it moves the decimal over 2 places. Okay. Now, this portion is really just our x, right? Because x is equal to this thing. So we could rewrite this as 100x equals 13 plus x. If we do some algebra, we can subtract x from both sides, and we end up with 99x is equal to 13. And then we could divide both sides by 99, and we see that x is equal to 13 over 99. Okay, let's just test it on a calculator to make sure we didn't make any mistakes. And we do get 0.1313131313. Okay, now we're going to do another proof, and that's the last one. So prove that the sum, let me get this out of here. Prove that the sum of any two rational numbers is also a rational number. Okay, so we're going to let x and y be two rational numbers, or we could simply say let x comma y, not like a ordered pair, but just x and y, be contained on the set of all rationals. We could also write it like that. So either way works. Like by the definition of like a rational number, we could say that p and q are integers, and q we're not going to let equal 0. And so x we could define as p over q. So P is rational, etc. Okay. Now, same thing, by definition, we could create two other numbers. Once again, S is not going to be equal to 0, and we'll define Y as R over S. Okay, so if we do X plus Y, maybe I should keep this in line. I'll do it down here. Okay, so if we have X plus Y, and then we use the new definitions for those, that means P over Q plus R over S. Okay, and if we add those, we have to get common denominators. So I'm going to do Q over Q, and I'm going to do S over S. So we get PS plus RQ over QS. Okay. Now we know that P, Q, R, and S are all integers, so we're just going to say that. Since P, Q, R, and S are all integers, because they were defined as integers right here. Since we know that those are all integers, we can say that an integer times an integer is an integer. So we know that this is going to be an integer. We know that this is going to be an integer. We know that this is going to be an integer. And then we know if we add two integers together, we also get an integer. So the top just becomes some integer. I guess I'm going to have to go to the side now. So the top is some integer p, because if we add two integers, or if we multiply two integers, we get integers. If we add integers, we get integers. So we're just going to call this entire top capital P. And then the bottom, same thing, we multiply, and so we'll just call that capital Q. And we know that P is an integer. We know that Q is also an integer. And so P and Q, one thing further on Q times S. Q and S were both defined as not being 0. So we know that Q is not only an integer, but Q is not equal to 0. And so if we do P divided by Q, that fits the definition of a rational number, and therefore X plus Y is contained on the set of all rational numbers. So we just proved that if we add two rational numbers together, we will always get a rational number. If you need additional help, please come to Math Lab. Until then, calculator.